Hello guys, welcome to this live stream. Um, so, hello guys, welcome to today's stream. Today's stream is going to be a short one. Really not gonna it's not going to be that long. You gave her 50 because hello guys, because of the subjects we'll be talking about. Um, yeah, so we'll be talking about variable bindings in Rust. So um, I don't know if you guys can see me. Please, if you can see me, let me know. Guys, please leave a comment in the chat. Also, on YouTube, please follow me on YouTube. I'll be leaving my YouTube link. You'd see it on the screen, basically, right? So, and you can follow me on YouTube. Yeah. So, once again, welcome to today's Rust programming live session. I'm very excited to dive into these concepts with you guys. I wasn't really prepared for this stream. Wasn't really prepared. Well, I still have to do it. I have to do it one way or the other. So I didn't inform a lot of people about it. I just decided to do it this morning, right? It was a spontaneous decision, but I'm super happy that I'm doing it. So, once again, welcome everyone to today's live session. We're going to be talking about variable bindings. It's part of our Rust by example series. If you're new to Rust or you just want to strengthen your fundamental knowledge, this is a place for you to be, right? You learn a lot from this from what I'm going to be doing today, right? So I'll just take a moment to quickly adjust my image icon on the right screen to on the left to the right of the screen, so that we'll be able. Sorry about that. So you'll be able to see when I put something on my screen. So I think I would. I don't know how I do that. So I'm new to this streaming software I'm using. Currently using a different streaming software, and it's a lot. So I'm still learning how to. I'm still getting used to the whole thing. But anyways, let me just leave it there. Let me leave. Okay, I think this is it. This should be it. Video settings. Nope. No, I don't think so. Okay. Okay. Anyways, so if you take a look at my VS Code, I've made some changes since the last time we had a stream about Rust examples, right? Um, I I made some changes to the code base to make it more organized and all that. So I've been able to move my stuff. Okay. So I made some changes, to be able to make the code itself more organized, cleaner, and easier to reason about, right? So I'm just going to quickly explain all that I've done Yeah, I'm just going to quickly explain all that I have done. So if you take a look at my screen, you'd see a couple of files from our previous stream. So I have the custom types, right? So everything we did about enums, structs, everything we did about enums, structs, and the use type, I had put them in this file and imported everything into the main file. So there are about 3 functions there according to the 3 steps that we went through in that tutorial. And guys, once again, I apologize for my video quality. Should be fixed soon. So that should be fixed soon. My next stream is not going to be this poor in video quality. But let's just go on. So I did that, and also for today's own live stream, I also added a new file, and there's a lib file, right? Where I import those 2 files and make them public so that I can import them into the main file. So today's live stream, I'll just comment out the ones we did from the previous stream and save. And then I've already imported the bindings here, which is the function that we had defined here, right? In this in that other file, which is the variable underscore buildings.rs, right? So yeah, that's it, right? Yeah, so I think that's basically all. That's all. So another thing I wanted to quickly talk about is the way I have imported these things here, right? So I could actually do it in one. I could do it like this. So I'll put it in the curly brackets and there custom types and custom types and star. So what that star means is import all the public function from our module. That is a custom type module. Then I can also do the same thing for variable bindings. All right, I can do that in one line. Yeah, I can do that in one line, right? It's still the same thing. This is the same thing as this, right? So at the end of the day, it brings all of them into brings everything into scope. So this would still work. So I forgot to put my yeah. So I will just comment this out and leave it for the purpose of learning, and also yeah. So we'll just make use of this one I just added. So it's still the same thing, right? Anyone works, basically. So back to what we'll be doing today. Another thing again is I'm no longer going to be running cargo run for every time I make a change. So I'm going to use a command. So cargo watch x and run, so that each time I make changes, it will automatically run it for me, right? So this is cargo run and it will build and stuff. So while it's doing that, um, so let's just forget about code. But what I can do is I can just comment out custom types since we are not using it. So I wouldn't get things logged to my terminal that are not in the current scope of the live stream that we're having. So today's lesson is going to be very short, right? It's not going to be like our other live streams that gets to like an hour. Today is going to be like highest 40 minutes, maybe 30 minutes. And this is almost 15 minutes. And I'm still doing introductions. And so guys, please consider dropping a comment. It helps. It doesn't hurt to say, ask questions in the Q&A section that is in the comments, or just say something in the comments. It helps, right, with the algorithm and everything, to push this video to people that would be interested in learning from it. So if you look at the screen, you'll see my YouTube link is there. You can follow me on YouTube, drop a comment, just support your boy in what I do. Anyways, so let's go ahead. So then I'll go back to this file, close this, and close this. So here I already have a function, and the pub there, see there, means that this function is public, right? So I'll start by saying that in Rust, you can explicitly specify the type of, a type of variable. And, so this is all part of the, variable bindings in Rust. So you can explicitly specify the type of a variable, but most of the time, the compiler is smart enough to figure it out for you, right? So the compiler is smart enough to know the type of variable that you're defining, right? Okay, so we'll start by, you know, let's declare something like an integer, right? So we'd say, let's let an integer be equals to 1. So the compiler would know automatically that this is an integer, and it would append a type of i32 to it, right? So I'm using something called Rust Analyzer, and that's what suggests. I think it suggests this stuff for me. And if I go ahead and I double click it, it's kind of inserts it there for me. So this is just like an easier way to, a faster way to do things. It's not a must to put it there, but it is good practice to put it, right? But this is kind of like implicit. So this is like an implicit way of doing it. One thing to note is integers have by default a type of i32, right, in Rust. So for the explicit binding, I can explicitly at the end of that number say I want it to be a u32, right? And once I do that, you would see that the type here has automatically changed from an i32. The type that the Rust analyzer said to me has changed from an i32 to a u32, right? So it's no longer an i32. It is now a u32, right? So I had to stop that stuff from continuously running. I guess that was making my screen to lag for some reason. I don't understand why. But back to what I was saying, um, so we can explicitly set this value here to any of the integer types that we want, right? So in this case, we are explicitly saying that this is a u32. I can go ahead and change it to, let me say, one should be an i8, right? So an i8 is an integer type. Save this and let's see what happens. Yeah, so you can see that the Rust analyzer has just updated it to be an i8. So this is kind of like an explicit way to, define an integer. So we'll go ahead and do that for a boolean. So a boolean, and a boolean is either true or false. So in this case, we'd say it's true. Save this. And we'll also do the same thing for a unit type. So let's unit. So unit type is an empty tuple in Rust. So tuples are represented by parentheses, right? So just basically brackets, not curly brackets. So curly brackets are different from like, brackets and all that. So you can see that Rust, tells us the Rust analyzer is saying that this is a type of a bool, and this is a type of a tuple. So one thing we can do is we can also copy an integer into another variable. We can copy a variable into another variable. And how we do this is, for instance, we can create another variable. Let's say, first of all, add a comment. I'll say copy what we have on line 2, which is an underscore. Just copy that stuff. What we have here. Into a new variable that we'll create. So we'll call it copied integer, right? And here we'll just say let's copied, so that name. So that name copied integer be equal to our integer on line 2. Okay. An integer, right? So we can do this, right? So we've copied, so you can now see that this variable, which is copied integer, is now a type of 32. So Rust analyzer is automatically saying that this is an I32 type, which is what we had explicitly set it to be here on line 2, right? So let's go ahead and print some things to the terminal. So I'll just do print line. So I'm going to print 3 things. I'm just going to duplicate this into 3 places just to save time. Okay, so in order for me to format my code for it to look a little bit clean, save that file and the usual cargo fmt. Okay. So that will format the code. Everything will look nice. Okay, so we are then going to go ahead and print some things to the terminal. So here we have okay, expected. Oh, let's see. I'll go FMT again. All right, so now we have our formatting here for us. So we'll go ahead and we'll print our integer, our boolean, and our unit type. So I will just quickly write that out. So say an integer, right? And I'll say integer. Okay, so in this case, we want to, print our copied integer, because if you remember, we had, binded it to this variable here. So say copied integer, so log it there, print it there. Sorry, the JavaScript in me doesn't let me all the time log because of JavaScript. So then we'll go ahead and do the same thing for boolean, and for the boolean we would have same thing, and we'll call a underscore boolean, and for the print line we'll just say let's say meet the unit value, right? And just the same thing, pass our unit here. So I'll save this. And when I save this, if you remember, so once I save this, all these yellow lines and warnings would automatically disappear, because I've now saved the file. I'm now using those variables, right, in my print statements here. Yeah. So after I'm done doing this. If you remember, we had imported bindings as a function into our main file here, right? And we had imported our variable bindings, that is this file, into this place, using the use word from Rust. We also had to pass it as a as a module in a file called the lib.rs, where we also made public, right? So in case you are wondering how I'm able to import this file into the main into the main file, which is the entry point for every Rust application or exam, right? So now I will just clear here and go ahead and I'll go ahead and run the code. So I'll say cargo run. So I was supposed to use the automatic um, way. That is the other way I said I was going to do, where it just runs everything. For some reason, the streaming I'm using keeps hanging. So I just decided to end that and just do it manually, since this live stream is not even going to be too long. So if you take a look, you already see that in the terminal, we have all our values being logged here, right? So we have an integer of 1. So we had set it to 1. Our boolean is true, and we have a unit type of an empty tuple. So you can see that's logged here. So I'll clear this and then reduce this. Yeah. So one thing to note is we were able to copy this integer, which we declared on line 2, to a new variable called copied integer. This is possible because of something in Rust that we call the copy traits, right? So integers implement a trait called the copy traits by default. So there is a Rust documentation for that. So if you take a look, you'll see the copy traits. You'd see how it's implemented, how it's used, and all that, right? So you can just dive into this place and then take a look at. Hold on, let me see. Yeah, you can dive into this and just go, and if you want to geek away and read more about how it works. But basically, integers implement the copy trait, and that's why we are able to do what we did here on line 7. All right. So next we are going to unused variables. So if you take a look, when I had not used these variables, there was like yellow squiggly lines under it, right? So Rust is all about helping you write better code, right? So if you declare a variable that you've not used, the compiler would warn you, that, hey, look at this code, you've not used it. Either you make it such that I can ignore it, or you take it out, right? So we're going to write some code. So I'll just go ahead and say let's unused on UNUSED unused var. Let me say unused var. We'll do our explicit binding. So we'll say 3, and it will be a type of view 32. So let's do 32. Yeah. So then we would have so that is for the unused var. So I would append an underscore here, and I'll create another one, and I'll say let noisy var be equal to a type of 2u32, right? So if I save these 2 lines of code, something is going to happen, right? So let's just take a look. Something is definitely going to happen. You'll notice that I had appended an underscore to this first variable. So because I did that, this is not going to error out, right? But if I compile this code, the compiler is going to tell me that the noisy var is an unused variable. So if I want it to stop, if I want to suppress that warning, I could just go ahead and prefix an underscore, just like I had done here, right? So my Rust analyzer is is very, very slow today. I don't know what's happening. But basically, if you take a look, you would see that I'm getting this one here saying unused variable, noisy var. It has the one unused variable stuff by default, right? So now, same thing is not happening to this like on line 13, right? And this is because of the underscore that we have here. So hence, if I want to suppress that warning message, I could just go ahead and add that underscore here, right? Once I do that and I save, you will notice that Rust Analyzer. So guys, the reason I'm using Rust Analyzer is because it makes it faster. I think, in my opinion, it makes it faster instead of always compiling and compiling, and we can see the errors in in VS Code in real time, right? So instead of compiling and compiling, you just see it in VS Code and try to fix it at least. But the error message that the compiler gives is more in depth and more explanatory, right? So if I take this out, I save, and I come here and I do cargo run. So to build, okay, let me check. So you can see, right? So you can see here that it says unused variable, not var, right? It's mentioning the name. And it went ahead to say it's in the source file, in the source folder, and there's a file called variable binding.rs, and it's on line 15, character 9, right? So line 15 character 9. I don't know how they calculate it. I don't know if it's the alphabets or if they include the sync, it will be the alphabet. So we have 3, 4, 5, 6, 7, 8 underscore 9. I don't know how they do the calculation, but basically, I think character 9, maybe it could be the spaces it starts from and all that. Then it goes ahead to say on that line 15, we had declared a variable called noisy-var, which is an integer of type U32. So it goes ahead to say, help, if this is intentional, prefix it with an underscore. So do this. So the Rust compiler is telling you to do this, right? So note that it's implemented, that is the one unused variable, is on by default, right? So you can see how explanatory errors are in Rust. And this is one thing that makes Rust better than so many languages, because of the excellent error messages that you get from the compiler, right? It's so nice that you can hardly get things wrong, right? You can still get things wrong, but most of the time you get a lot of help from the compiler. All right. So I'll just go ahead and prefix that underscore because I hate seeing errors in VS Code. I hate seeing those yellow lines, and I'll clear this. Then I'll reduce this and save again. Then let's go on to, so I'll add comments. So the first one we learned about was variable binding. So everything we did here is variable bindings. The second one here is the second one is unused variables and warnings. So I'll say used variables and warnings. And next we'll go into mutability, right? So guys, please drop a comment. If you have any question, please, you can always ask in the in the chat. So you'd see the stuff on the screen where you can ask me questions. I'm trying as much as possible to make the whole session engaging. I'm really new to this whole streaming stuff, so I'm kind of like winging it, right? So it wouldn't be 100% perfect, like the big guys like the Primogen and the rest of them, right? So I know definitely I'll get there, right? But please ask me questions where you don't understand. If I don't know it, I would go through it together, I'll look for the answers and everything, but just ask me questions. Let's try to keep it engaging. And please leave a comment. Please, nobody's leaving a comment. I don't know what I've done to you guys. I'm seeing about 24 people on the stream. please, 24 persons is a very big number, right, for such a subject, right? Even if I see one person here, I'm okay, I'm happy. Please leave a comment. I really need it, and it will really make my day, right? So thank you for coming on the stream once again. I appreciate you all. So next we're going to talk about mutability. So mutability, I'll add the comment. Mutability. So by default, variables in Rust are immutable. And what that means is once you assign a value, you cannot change it, right? But if you want to make a variable mutable, you can use something called the mute keyword, right? So let's write some code to explain this. So first things first, so I'll say so from henceforth I'll be using the underscore because I don't like those yellow lines, right? So I'll say underscore immutable binding. I'll set this to 1. I'll say this is 1. And I'll declare down and say let. So this the first one is immutable, which means I cannot change the value. The second one, I'll add the mute keyword and I will call it mutable binding. I'll set it to 1 again, right? Yeah. So I still use the I will still use the underscore because I don't want any errors. I don't want all those squiggly lines. Okay. Yeah. Okay. So now let's print, right? So I'll just do a print line. Print line. And here I would pass something. I would say so before mutation, and I will do after mutation just to demo the whole process, right? So now I'll say before mutation, right? I'll just pass squiggly brackets there, and I'll pass the mutable bindings, right? So mutable binding, I'll save, right? So I'll remove the underscore here. I don't need it again. All right. Yeah. So now print line cannot find macro print. Oh, print ln, not print lane. Print line. Yep. All right. So now I'll quickly variable does not need to be mutable. Okay, so I will just go ahead and I would say mutable. So mutable binding 1. Yeah, so I'm mutating it here. So hence the reason we're getting this warning is it doesn't have to be mutable, right? Because we are not actually mutating it at that point, right? So I'll just add in. So this is where I'm now doing the mutation. So hopefully once I save, that error should be gone. Then I'll print line again. Print line. And here I would say after mutation. Then I would also pass that mutable bind again. So I'll call it mutable binding. I'll save. All right. So after doing this, I would then come down here and of course you can see that the error has disappeared, right? So if we're not mutating, there's no need of adding the mute keyword. That's what my Rust analyzer was trying to tell me, right? So now we are now mutating on line 25, so that error message has somehow disappeared. So now on line 29, let's try to mutate the one that does not have the mute keyword, and let's see what will happen. So basically we'll get an error saying we cannot assign a new value to an immutable variable, right? Something that cannot be muted, like mutated, you can't assign a value to it. If you cannot change something, you cannot assign something else to it. Right? It's just like I don't know the right analogy for this, but something that cannot change, you can't name it something else. I don't know if that makes sense, right? So I'll just go ahead and say the one on line 20. So I'll say immutable binding, and I'll try to mutate it. And let's see what will happen. I'm already getting that error message. Cannot mutate immutable variable, right? The only way I'll be able to do this is if I now add in the mute keyword here. Of course, that's not what we want to do, so I will not add that, right? So we'll get this error message that we cannot mutate that. So I'll just add that error message. I'll write it as a comment here. So I'll say there will be an error. Cannot mutate an immutable variable, right? So yeah, so that's for that part. So looking at this, you can see how we've successfully first of all updated the mutable binding on line 25. But we got an error when we tried to do the same thing on line 30 because of the difference that we can see on line 20 and 21, right? On line 20, we don't have the mute keyword, right? So if I hover over this, I can even see some suggestions from, there is this, I think, tab 9. I don't know if this is tab 9. So that there is a plugin I have in my VS Code that explains, some of these things. I think it uses AI or something. I don't really know, but it's saying here that the mute keyword, that's this MUT, immutable variable, reference, or pointer. So mute can be used in several situations. The first is mutable variables, which can be used anywhere. You can bind a value to a variable name. Here are some examples. So you can see something similar to what we just did. So here they are binding the value of y to x, right? Same thing here. So here a variable a was defined and mute was added to it, and it had the value of 5. And in the second line here, they are changing that value from 5 to 6, right? So this is just like, that's what the mute does. So the major difference here is what we have on line 20 and 21. On line 21, we said we want the mutable bindings to be possible. We want to be able to mutate, whatever this variable is, and we're able to do that here, and we don't have any errors. But on line 20, we did not add any mute keyword. We just declared a variable. When we try to mutate it here, we get the error message saying cannot mutate immutable variable, and it also gave us the name immutable binding. All right. So one thing this thing does is it helps us avoid bugs to the greatest, to the largest extent in our application. You're writing Rust, right? So it helps us avoid code to the greatest extent. So I'll just go ahead and comment out these lines. Oh, no, let me leave it. I'll just go ahead and run cargo run, and let's see how the mutation works, right? I'll quickly say how I know it would work. Then I'll go ahead and run the code, right? So here we have print line before mutation. So we are printing mutable binding, which is 1. So here we would have 1, and then later on we now mutated it. So what the plus equals to mean is just add another value, add whatever value we have here to what the previous value was. So this would now mutable binding will now be 2, right? So when we print it on this line, instead of having 1, we'll then have 2, right? So I'll save this and I would carry on. Let's watch it build. So guys, please leave a comment. I don't know why you guys are not leaving comments. I don't know. Have I done something wrong? Please leave a comment. Follow me on YouTube. I really appreciate. So as I just explained, you can see, so forget about these ones at the top here. So this was from our previous, and this one we talked about variable bindings. So let's just focus on the mutability aspects, which is here. So you can see that before mutation, our value was 1, as we had already set on line 20, and we printed it on line 23. Then we mutated it on line 25, right? We added 1, and I told you it was going to be 2. And as you can see here in the terminal, after mutation, the value now becomes 2, right? So yeah, that's basically it. So next we are going to talk about scope and shadowing, right? So we're going to talk about scope and shadowing. So I'm going to add a comment here. Say scope and shadowing. So guys, once again, these are all concepts that you can find in the Rust documentation. Rust by example documentation is a very, very, very wonderful resource if you want to learn the language, the Rust language. It's one of my go-to source after the actual Rust book, right? It's very practical, contains a lot of code and practical ways for you to learn the language. If you're not interested in a lot of words and you just want to show me the code and write the code and stuff, right? It's a very interesting way to get to learn the language in depth too. So guys, please leave a comment. Can ask me any question in the chat and we'll be willing to answer any of your questions, right? I will be willing to answer your questions. Thank you. So moving forward, let's talk about shadowing, right? So variables in Rust have a scope, right? You have a scope, and this scope is only valid within a block. What is a block in Rust? So a block is curly brackets, something like this is a block, right? So that is the scope, right? So if we declare something inside this block, that thing is only available within the scope of this block. We also have other scopes in this place. So if you look at this is a scope. So this is the scope for the entire binding function. So it starts with the opening curly brace and ended with the closing curly brace. Right. So if I close it, you see it closes all the function. So that is also a scope, right? So without wasting much time, let's just go ahead and write some code and explain how this whole scoping thing works, right? So now I'll declare a variable. And I would, okay, so I'll just add an underscore here, here, and here so that I can comment out the print and I will not get any errors. I'll also add here. So I'll comment out this guy. Don't want any errors, any warnings. I also add underscore here because I don't want any warnings. Yeah, so I'll comment out print and print. Yeah, so we are fine. So we can go on with our scoping and shadowing. So now also clear terminal. Yeah, I cannot bind not in scope. So comment that out. So the first thing I am going to do is in the scope of my binding function, which is on the same level where I've actually declared all these guys. So the unused variable, noisy variable, copied integer, blah, blah, blah. Cannot find the value of integer in this scope. Okay. All right. Let me see. Okay, maybe I'll just remove this and remove this. Save. See, that error should be gone. I hate seeing errors. I hate it. Yeah, so that should be gone. So apparently I just have to add that underscore here. Okay, because of course I've binded this to this, right? Makes sense. All right. So as I was saying, on this same level, right? So these are all on the same scope, right? They are all on the same scope. So I'm going to create a new variable. I'll say let's what's my time? Okay. So I'll say let's long lived binding be equals to 1. Then I'll create a new scope. So like I said, curly brackets. And in there, I'll say I'll create another one. I'll call it short-lived binding. So I'll just copy this, write it up again. So I'll say let's short-lived binding equal to 2, right? So always forget to add this. All right, then because I don't want any errors, I'll just add an underscore there. case if I'm not yet using it. It's the one I want to use it. Oh, just leave that out. Then here, I would then say I want to do a print line, right? So print line, and in there I will say inner shots, inner shots, inner short. And for that inner short, I'm going to print the short-lived, right? So the short-lived variable. So I'll say print short-lived binding. And when I run this code, something happens, right? When I run this code, something will happen, but not yet, right? Then outside of this scope, I would then try to still print this guy. I have in this curly bracket block, try to print him out, and also try to print this guy out here, right? So I would say, let me copy this, paste it, and paste it again. So here I will say I'll call it an outer short because I just want to print this guy, short-lived binded value here. Then outer long, so I'll change this to long. So for the long variable, outer long. So I'll change this from short-lived to long-lived, right? Nice. Also, what I would do again is I would also say I also add long-lived into this place, right? So I'll paste this. I'll call it inner long, and I'll change this to long-lived. So you can already see that we already have an error, right, from my Rust analyzer. I'm already having an error here. It's saying cannot find value of short-lived binding. Right? We can, of course, we'll not be able to find it because it is on a different scope. It is inside this block. Despite the fact that this block of code sits on top or before this line of code, but they are not on the same scope, right? Because this guy, the short-lived binding variable, is inside a different scope. But if you notice, we don't have that same error here on line 38, right? And the reason for this is even if we are we are printing long-lived binding in this scope has access to everything that is outside of it, including what is inside of it, right? So we have access to everything that is inside here and everything that is outside here in the scope, in this particular scope. So that's why we are able to print. We're able to print long-lived binding in this place without having an error. But here you can already see that we already have an error saying cannot find value of short-lived binding in this scope. So they're not on the same scope. So guys, in case you're wondering how am I able to see all these errors in my terminal and stuff, in my VS Code, I'm using something called Rust Analyzer. If you can just install it in your VS Code and it would help you suggest all these things. So you don't have to always build all the time, right? I just find it I find it to be an easy way for me to, get to see errors before I go ahead to build all the time. So you can already see that we have this error here saying cannot find value short-lived. So this is because they're not on the same scope. So I'll just go ahead and I'll run cargo run just for formality's sake. Let's see what we get. So it already breaks, right? It will not even compile in the first place, right? Because it gives us a more detailed error message in this case, right? We have a more detailed error message. And here it says, cannot find value short-lived in this scope. It's telling you to go to the source folder. In there, you have variable bindings file, .rs on line 41. So you can see on line 41, character 33. So it goes ahead to suggest to you and says, help, a local variable with similar name, blah, 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 and all that, right? Similar name exists, which is long-lived binding. So basically what it's trying to tell you is that it is not in the scope. So because they are not in the same scope, you can't get it, right? So if I go ahead and I comment this out and I run my code again, run it, shall go run. So it should compile this time. Exactly. So you can see that we have the inner short, which is 2, which is defined here. That is it here, inner short. And we have the inner long, which is this, which is declared outside of this scope. But because this is a scope nested in another scope, we have access to everything that is outside of us, right? So we're able to print long, inner long here. Then we're also able to print the outer long, which is still 1. So now let's now look at shadowing, right? So this is where it kind of gets very interesting, right? So Rust allows us to shadow, and shadowing means that we can reuse the same variable names in different scopes, or even reassign it with a new value. This particular functionality of the language or feature of the language is very tricky and risky to use, right? I've not really seen the use case where I want to do that, right? But I know it can be super helpful when you want to transform data while keeping the original intent clear, right? Well, I would basically not do it. I would basically not use it in my own implementations or in my own code. It's not a feature I think I would use, but I think it's pretty cool. And I decided to talk about it, right? So, shadowing, right? Let's talk about shadowing. So now I'll create another variable. I'll call it, I'll say, let's shadowed binding, let's say is equals to 1, right? 1. Good. So we'll create another scope, a different scope this time around, right? We don't want to use this. We'll just leave this scope for, let's call it our scope. Our scopes, listing scope. We'll create another one and we'll call it our shadow distance, shadow scope. Shadow. Create this scope. And inside our shadow scope, we're then going to do something similar to what we had done before, right? So I'll just get this name, shadow binding, and I would say let's shadow binding with this, and I'll set it equals to the ABC. So a character type, was this. Then I'll just do a simple print line, right? So take this guy, don't want to write much, and put it here. What's it saying? Oh, yeah, I can't have to use double quotes, not single quotes. Yeah. So this is a string slice. And yeah, so next I would then say shadowed inner block. So I'll change this to shadowed inner block. And here I will just print shadowed binding, right? So we have this. The next we'll go over and go over for our this is shortly okay. I'll take this to the top just to keep it together with when we did what we did for scoping. So I'll put it here. I'll just save. I'll do cargo fmt just to have a clean workspace. Exactly. So we're already having that error saying unused variable, right? So we'll just come down here, and the reason is unused is because, right, we've not okay, yeah, it's unused because we just declared now we've not done anything with it, right? Even though we use the same name in this particular scope, right? It is still seeing the compiler is still seeing it as unused, right? So let's go ahead and use it outside of this scope, right? So let's say let's shadow shadow binding equals to 2, set it to 2, and I'll just print line. Right, so take this out. Okay, so I'll call this shadowed outer block. Shadowed outer block, and I'll pass my shadowed binding here. Right. So you can notice how, one thing to take note, I know I already mentioned, is to notice how the shadowed binding here is taking, this variable is taking a different, it's taking a different value based on the scope. So here we took a type of I32, which is one, an integer type. And here we're taking a string slice, right, of ABC, right? So you can begin to see how how shadowing enables us to take different values depending on the scope, right? Based on the definition I gave. But this is something I will really not do. I don't think I will have any need to do that. There is no scarcity of variable names, in my opinion. So I don't really see a reason why I would want to, use the same variable name in a different scope, because it can easily get confusing for the next developer that comes. But this is just my opinion, right? I stand to be corrected. But yeah, I don't see myself doing something like this, right? Using the same variable name but in a different scope and assigning a different value to it. Things can easily get very complicated with doing this, right? Anyways, yeah, um, so I have shadowed binding and all that. And yeah, so I'll just go ahead and run cargo run. Cargo run. Yeah, and I should have, like, if you take a look, you see the inner shot. So I have like the inner, I still have my inner shot and all those things running. But if you take a look at what we need here, which is the shadowed inner block, we have ABC, right, using the same variable name here. And we have the shadowed outer block, where we gave it an integer of 2, right? So yeah, next, let's talk about declaring variables, right? Declaring first variables. So in Rust, you can declare a variable first and then initialize it later. But this is another thing you have to be very, very careful about, because uninitialized variables can be used, can't be used, right? So I'll just add a comment here, speaking to declaring a variable. So I'll say declaring variables first. I'll save this. And okay, so the first thing I'll do is I'll just declare a variable, and I'll call it let's a underscore binding. Let's just declare a variable, right? So this is a variable, and then we'll create a different scope and we'll say let's x be equal to 2 or 3, and we'll then say our a underscore bindings is equals to x multiplied by x, right? So we can do this. Don't mind the stuff, the warning messages. So outside of that scope, I'll then go ahead and print line, and I'll say a binding, and let's call it a binding. Save, and you can see that those error messages have gone. Yeah, so this is for the first part. Then Next, let's declare another variable and try to use it without appending a value to it. So let's say another another binding. So we'll just declare this. So this would give us an error if we try to um, to print it, right? So let's say another binding, and here I'll just pass another binding, right? Yeah, so I'll save this and I'll have an error, right? Um, basically, what's it saying? Um, an explicit type. Uh, okay. Okay, this is okay. This is saying consider giving it an explicit type. I should be seeing an error, a different error, but when I run it, let me run it and see what happens. Cargo run. I should be seeing an error. Okay, saying give it an explicit type annotation needed. Okay, so let me just say this is an I32. Hopefully that works. Okay, yeah, so I've given it an I32. So it's now saying used binding. Another binding isn't initialized. Okay. So I have to like explicitly say what I want this guy to be in order for me to be able to use it in the first place. So go ahead and cargo run again. And you should see that error, right? We'll see the error saying um, another binding used here, but it is not initialized. So like I said, you cannot use a variable that you have not initialized, that you've not added something. So I'm just going to add a comment here with that error message. So another binding isn't initialized. So I'll say it's an error. Yeah, it's not initialized, right? Then down here, I would then say another binding, right? That same another binding, I would then equate it to, let's say 10, right? Remember, on this line, it is not initialized, but here we have initialized it. So we can go ahead and print, copy this guy, and paste it here. So here we are going to print another binding, just the same thing, right? So if you save this, and let me run code and see what happens. Try this first. Cargo run. Okay, it's not letting. It's not letting binding declare, but okay, left uninitialized. Okay, so I'll just comment this out. So that's for the purpose of learning, and I'll save. I'll run this code again. I should be able to see another binding, the value of another binding, which is 10. So you can see here we have the value of another binding to be 10. So this is where Rust becomes a lifesaver, right? Because if you try to use an uninitialized variable, it will throw an error. And this error prevents undefined behaviors, which is a common source of bugs in so many other languages, right? So lastly, we'll talk about freezing, right? I wouldn't really go into this because I would say you can research about it. So there's a concept called freezing. Um, if you basically what it says is if you shadow a mutable variable with an immutable one, the data becomes frozen. So you can't modify until the immutable binding goes out of scope, right? I'm not really going to go deep into this, but you can take that as something that you can look into, try to research it, try to understand what freezing is. But it's a very important concept for one to understand and for one to master. So, guys, I would say this is a wrap for everything on variable bindings. The only thing I could not touch on because of time is freezing, the concept of freezing. And probably I might make a short video about it and just quickly talk about it and all that in some other video. But we've covered immutability, mutability, scoping, and shadowing. And so these concepts might seem simple, right? But they are the building blocks of Rust itself, like Rust memory and safety performance. So guys, if you enjoyed this session, don't forget to leave a like, share, subscribe. You can always drop your questions in the chats, and I would answer them when I can. So I'd say thank you so much for joining me in this session, and I will see you in the next one. Bye. Peace.